Today on the Messy Bench, we have a speedometer cluster from a 2010 Toyota Tundra. I bought this cluster off of eBay because the cluster that's in my 2010 Tundra, the voltmeter has stopped working. It seems to be stuck somewhere right over here and doesn't move no matter what. So I bought this cluster off of eBay as an experiment to find out what it would take to get this torn apart. And looks pretty simple to get apart. I have worked on speedometer clusters before, but I have never worked on a Toyota speedometer cluster before. So I wanted to find out what all was going to be involved to get this apart and do some experiments. And that way, if I make a mistake, it's on a cluster that I care less about than the one that actually goes in my truck. Plus, I figured if I need this stepper motor, then I've got parts and that kind of thing. I looked on YouTube and I didn't see any videos on how to take one of these clusters apart. I saw a number of videos, but none of them ever showed how to actually get to the cluster, how to remove the cluster from the truck, or how to get the cluster apart. One video goes into a great amount of detail explaining how to change all of the LEDs in here, and they give you all the part numbers and stuff for the LEDs, but they don't actually show the cluster torn apart or any of the work being done or anything like that. So I thought I would take this one apart and see what happens. So let's get into it. So to start with, it looks like the halves of this cluster just come apart here. Looks like there's these little tabs here that we can just press to remove. And let me see here if I need a tool here. Looks like, yeah, it looks like we can just push on these tabs here. I'm not even using much force here. And we can get this plastic here to come apart. See if I can get a screwdriver in down here someplace to get a little pry action. Yep, there we go. And seems to be coming apart pretty easy here. Of course, there's no real good way to hold this thing, but so we'll start by just removing the clear plastic, and it looks like the same thing on this side here. There's just some tabs here, and you'll notice this pink paint on it here all over the place. That must be from the salvage yard that this came from off of eBay, trying to mark it so that way people can't return a cluster and say, oh, this one was bad. Oh, see, look at that plastic piece came off pretty simple. And with this plastic piece, this has got some swirls and stuff on here. I'll take some rubbing compound and polish this piece up, and maybe I can make it look better than the one that I've got. So I'm going to put that aside for right now. And now we can take a look at this cluster here. Mine is a little bit different as I have the tow package and I've got a transmission temperature gauge here. But it looks to be similar enough that this should be what I need. Looking at the Toyota wiring diagram for this, I don't see that there's a separate voltage input. There is an ignition line, a battery line, and a ground, and it must run off of one of those three. So we'll take a look at that wiring diagram here in a little bit, and we'll power this cluster up and see if we can't figure out what makes that actually work. And I know I'm probably not doing this the best on camera here. Oh, look at that, the whole thing just came apart. So there's just some push tabs there, and then this whole piece will come off. Pretty simple. Set that off to the side here. And get a good close look at that here. Try and get this on camera if the camera will continue to focus. I don't know if it will. There we go. This looks like a piece of plastic. And these will have to pop off, I'm betting, to get in there. But before we do that, I see there is a back cover here and a couple of screws that we'll remove. And see what happens there. So, I see this is going to be a problem. And unfortunately, I don't know how that gets removed, so we'll have to set this up. And see, already just noticed that there is a broken clear tab laying on the bench here, so I don't know if I broke that or if it was already broken. Come on, camera, focus. So, see, that's something to watch out for, is those tabs are pretty fragile, I think. What a bummer. Okay, let me reset the shot and we'll get the back off. Okay, I have this propped up on a box, and so you can see what we're doing here. There is a couple of screws on the back here. We will see what happens when we remove these screws. Hopefully a million springs and ball bearings don't go springing all over the place. I highly doubt it, but these look like standard plastic screws here. I'm betting this exposes the circuit board on the back. And it looks like 4 screws total, if I haven't missed any. And see, there are plastic tabs here also. So let me see if I can find something to use as a tool to press on those. See if we can't get this apart. Can I hold this up and do this all at once without breaking it? Yep, there we go. So it's not just screws. There are screws and tabs that hold it together. And there's another one over here. There we go. Okay, so that side's loose. And there are tabs over here also. Pretty simple. And one over here. I'm trying to make sure I get this all on camera so you guys can see what I'm doing here. All right. Of course, I'm setting this up in a cardboard box, which is not the best, but this back cover now comes off, and we can see the circuit board inside. Well, we see the back of the circuit board anyway, and these are the stepper motors. Looks like standard S9 stepper motors. I think those are a standard part number. Or maybe they're 6S, I'm not sure, because they are upside down. And I don't know if you guys can see that there. Yeah, see, it says 6S. And there's some other numbers there, 091214 06-103. And then those PPE numbers underneath it, that's what it's made out of, what type of polypropylene. Plastic plus polystyrene, I'm assuming. 4607666 something. I can't quite read what that says there. 765 A1? I don't know how close I can get. Yeah, it looks like A1. 765 A1. And some kind of a buzzer on the back here. So it looks like the circuit board is just clipped in here, but I am betting that we have to get all of these knobs and dials off here first. Oh, and see, this one is already moved. Look at that. Just swings around. So it looks like most of these are just pretty free moving gauges here. And then, yep. All right, so that's good. So the question I have is, I'm going to have to try and figure out how to calibrate these gauges once you go to pull them off. And I suppose you can sort of see where the stops are, but how do you calibrate them? Yeah, it looks like there's just a stop in one place on all of these here. They will spin all the way around. Now, at least the speedometer, the stop is right at 0. And the tachometer, the stop is right at 0. So those should be pretty simple to remove. What happens if we just pull up on one? They don't just pull up. I see that this plastic's already coming loose. They don't. They're on there pretty good, which I imagine that they would be. So I'm going to have to figure out how to get that off. Let's take a look. Where are my pry tools? Of course, everything is here someplace on the messy bench. Here we go. Here's the tool that I was looking for. And I don't know what I can get on that I can pry on. And it feels like it's on there pretty good. And like I said, I'm doing this on one that I bought off of eBay, and therefore if I break it, it's not the end of the world, and I've learned what not to do. Oh, that just pulled straight off. And I don't think I broke it. Oh, and you probably can't see that on camera. Yeah, oh, you can. So I just pulled it straight up with a bunch of force, and it came off. And again, I have no idea how to calibrate this now to get this back on there. Looks like a tiny little hole there, and I can see in here. I don't know if you guys can see this, if this will help, but there's a little teeny tiny metal shaft in there that when you go to put this back on, we have to line this up. And see, like now the stop is here, so I just have this on here loosely. And I know that these were just a little bit past, but I'm not sure how you calibrate. Now, here's the thing with these clusters, these might do an auto calibration also when you power them up. Sometimes you'll see the cluster go all sweep up and then come back down. And when they do that, like speedometer, sometimes one, it looks cool, the factory does that, but what it's also doing is it has a timed amount of movements, and so it knows how long it'll take to get from full scale all the way down to 0. And so let's say that's 100 milliseconds or something. It'll count to say 200 milliseconds to make sure that the gauge is all the way down at 0 when it starts. And then at that point, it'll move up to wherever it's supposed to be. And of course, it's speedometer, but like the tachometer, for example, you start the truck, it'll sweep up, it'll sweep all the way down, it'll find its 0 spot, and then it knows to move up to wherever it's supposed to be. Same thing with the fuel gauge. That's probably how this works, but we're going to find out. One way or another, we're going to find out. So let's continue on. I'll just keep popping these off of there. And I'm just putting a screwdriver underneath the back, and I'm trying not to pry it to the side, so I'm grabbing the needle on the front side also and trying to pull up on both the front and rear at the same time. And you hear it just kind of pops off of the shaft there. So try not to put any angular force on it one way or the other, so that way I'm trying to just pry up and pull up at the same time, if that makes sense. And seems like that is working so far. This one's going to be a little bit trickier because I can't quite get on there at that angle. Oh, but it did come off. So now that we got that off, we should be able to lift this plate up. And so there is a little catch here in the middle, and there are some tabs here that hold it in place. So you have to lift it up off of the alignment pins and then slide it down to be able to pull this off. And we can take a look at the back of this here and see the masking on there. And now that we have this off, I can take a flashlight and shine it behind here. See all of the lettering that lights up. What I like about this is that this is a clear lens. This masking is clear, so that must mean all of the LEDs in here are all orange. And I've seen some people change these to white and blue, and it gives this a much more modern, nicer look, which I'm hoping to also do to mine, because I really don't like the orange LEDs. And so now with this off, We can see the circuit board in there and all the LEDs and whatnot, and we'll pull that circuit board off in a minute and examine it much closer. So now then, let's see if we can get this guy off of here in the same manner. I'm going to try a little bit bigger screwdriver here, and maybe I can get underneath here, and yep, same thing. I can just pry it up, and you can see that it's the same deal. I think they just use the same stepper motors. So I'm trying not to bend the motor shafts or break anything. And so far, so good. Okay, so here we have the little catch. And so we can get underneath this and lift it up off of this pin. And we can lift it up off of this pin. Now see, this one's a little bit trickier because this odometer reset button thing here is in the way. And so we have to sort of twist it and get it off of this pin and then lift it up. Oh, and look at that. There's some interesting notes right there. For mile per hour, white, minus 5%. Oh, and look at this. This is interesting information right here, too. This is really good information. 1 mile equals 1,025 revolutions. Area no visible. This must not be visible here. But now what does that mean? Does that mean 1,025 revolutions of the wheel or of the sender on the side of the transmission? Transmission has to move 1,025 revolutions to equal 1 mile. That must be how they count. Yeah. I like it so far. But that's good information. See, that's information that you would never find unless you take one of these apart. It's not in any of the Toyota manuals anywhere. It's not in the service manuals or anything, TIS. So this one has a pin at the top and a pin at the bottom, and we can lift that off. And where did I put my flashlight? Let's take a look underneath this one here. Traction. I don't know what that little symbol is. Steering? Stability control? No, that's stability control. I don't know. Steering, automatic transmission, oil temp. Check engine light, brake. And like I said, mine has another gauge down here. In fact, you can see where the hole would be for it on the circuit board here, where the other gauge is for the transmission temp. And I'm betting none of the parts, because the stepper motor's not in there, none of the other parts in there. And here's our LCD screen for the odometer, and LCD screen for the transmission gear indicator here. And let's take a close look at this now. And see how does this come off, because it doesn't pull straight up. I sure would like to get that off of there. And these look like they're just in sockets. So, but these being glass are going to be really fragile. So prying on these, boy, I don't know. Looks like they're coming up. And I'm being very, very gentle, because you could crack that glass really, really easily. I think you guys can see that. And so I'm trying to get underneath here in a very gentle manner. And there are pins right here that I can see are extended down into a socket. Let me see if I can show that to you guys here. And of course, this dumb thing never focuses when you need it to focus. And you see that socket down there, and you see these pins here? And so I'm trying to carefully get underneath here and pry up. And you cannot be too forceful on it, and you can't put too much pressure on it, because this is all glass here, and you will break the whole thing. And if you're doing this to your cluster at home, you would be in a world of hurt. But it looks like small little movements here, and I can get this to gently come out of the socket. All right, I'm going to set it down because it feels pretty loose. And I'm going to grab my little tool here. Now see, what did I just do there? God, I think there must be some residual voltage in it, or I touched it in a way that... I hope I didn't think I damaged it. But you can see the back here, and this whole thing is just glass. And see, all I did was touch the sides of it here, and I've already changed the way it looks. And so you have to be really careful with these. I'm just rubbing the back of this gently. So these are really, really fragile, all glass, and you can see that their pins just press into that display. And so I can tell just by looking at how this is built that in order to get that board off the back, these are going to have to come off. So I'm going to put this off to the side here, and looking underneath here, it looks like there is a plastic piece. Maybe I should have pulled, yeah, see, this whole plastic piece here comes up, and maybe when I do the odometer one, I'm going to try and lift by the plastic piece here. See, it's on there pretty tight though. Alright, I'm going to leave that one on there. See, it looks like on this one here, I don't know how I could get underneath that to lift it by the plastic. So I'm just going to do what I did before. And if I break it, I break it. And yeah, boy, it's really, this one's much more precarious because it's so much bigger. And of course, I'm trying to stand up and do this, and I can't see, so I'm going to sit down here and see if I can get underneath here gently. And see, all these prying movements like this are pushing it backwards also, and not exactly straight up. So it's a really this is going to be the trickiest part. I mean, I cannot stress enough how fragile these are. And so you're really going to have to be gentle. And I don't know, I think you guys can see I'm just using a hooked angle pick tool. You know, a straight pick tool might work also. Oh, I don't like doing this. This is really crappy. And I'm just putting the slightest amount of pressure on here to lift. Just a little bit at a time, rocking each side up, not going too far. And this is one of those Zen moments. Hold your tongue the right way and just take some deep breaths. Channel your inner Bob Ross. And see, I've already... It must be just some residual electrical charge that's causing that, because I touched the pins and it went away, but I think I don't think I cracked it. I think it came off in pretty good shape. You can see all of those pins on there that are very, very fragile. See, and this one here is already bent just a little bit for me doing exactly what I did, so we'll have to be very careful putting this back together again. But if you plan on changing the LEDs, you're going to have to do this to get it apart. I don't see how this comes apart, so I'm going to leave this on here for the moment. And I'm going to flip this over and work on getting the circuit board out here. And there are clips here all around on here that are just holding the circuit board in. So I'm just going to pick a point here, and I'm going to put my probe underneath it and pry up just a little bit and See, like this one I pushed on too hard and it bent pretty easily. It feels like these could break if you're not real careful. And so I'm trying to just be gentle. And it does not feel like it's coming up terribly easy here. I'm trying to figure out which way is the best way to get this off. See, it seems like it's coming up there. Feels like there's something holding it in the middle here, but I'm not sure what. I do see that there is a clip here. And I'm just working my way around it. And I'm going to put another little screwdriver here underneath it to help me work my way around. I know I really should have a much more elegant stand for this, but hey, a cardboard box works, and you know what? It's real world. Okay, feels like it's coming up just fine. Okay, work my way over here. Oh, there's a clip here. That's what it was. I was missing this clip here. I told you, I felt like something was still holding it. It was that clip right there that I was missing. Okay. Feels like I've got it loose now. Yep, I do. All right. I want to put this aside for a moment, and we're going to take a look at this back piece. Here is that plastic piece that comes in, and you can see it just clips in here. And so I'm going to, this is that, the button on the front. So I'm going to just pop these clips out of here. Oops. So I can pull this off, so that way when we go to put it back together again, it'll be easier to do. But move the cardboard box out of the way here so we got a little bit more room. Take a good close look at that. Just plain piece of plastic. Yeah, so let's take a look at this circuit board, because this is the interesting bits here. Yeah, lots and lots of parts on here. And look at all these LEDs. Let's see if we can count how many LEDs. 52 LEDs on this board. And so if you decide you want to change the colors of your speedometer cluster, there are 52 of these little teeny tiny LEDs right here. So to give you an idea, let's see if I can find something for a reference here. Here's an X-Acto knife. Let's get this in focus. For comparison here, you can see how small these little LEDs are. And so to remove these, you're going to need some specialized surface mount soldering, desoldering and soldering tools, some tweezers that will grab on and pull them off. And because they're LEDs, they have a direction, so when you go to put the new ones on, you need to know which way they're facing. And it's interesting here. Yellow, 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 I'm betting. Red, green, green, green. Yellow, yellow, red, green. I'm betting those are the color indicators. A. Now see, I don't know what A is. That'll be interesting. Maybe these are white? Amber. Oh, maybe they're amber. Yellow, green, red, blue, amber, red, red, amber. Yep, amber, yellow, yellow, yellow. Well, we'll power this up and we'll take a good look. So These chips here, these big ones here, are very likely stepper motor controller driver ICs. Let's see if we can take a look at what those are. And of course they're upside down. Can we focus here? Come on, camera. There we go. L4925SPD. Same thing here. What do we have here? What can I get you to focus? Mitsubishi M6 63823 GP. We'll look those up in a little bit. Let's see here. So these are going to be the main microprocessor ICs right here. That's probably a proprietary IC. Let's see if we can get it to focus here. Probably another proprietary IC. Very interesting. And see, here's the spot where the stepper motor would be for the transmission temperature. And you can see there are a number of associated parts, LEDs that aren't here, and other stuff that would make it work. But again, I don't need this board. I'm not going to reuse this part here. I'm likely just going to swipe this stepper motor off of here. This is the voltage meter here. In fact, let's grab that overlay and we'll take a look. So this is the overlay that goes on here. See if I can line this up. Yep, like this. And so you can see the 4 stepper motors here. Goes on here, voltage, temperature, oil temperature. That must be oil temperature. This one is the coolant temperature, gas gauge. And because these are all the same stepper motors, I'll just swipe that stepper motor off of there and replace it with mine. But it's interesting to get it apart and take a look on here and see what all the things do. So let me take a further look at this. I'll pull up the wiring diagram. We'll get some connectors on here. And we'll power this cluster up and take a look at what it does. All right, I'll be back. Okay, so I've learned a few things. These are not stepper motor drivers like I thought they were. These are 5-volt voltage regulators. This is our EEPROM chip where our odometer and trip mileage and everything is stored. And when you look close at these LEDs, you'll notice that there is a red LED really close to this motor shaft here and an amber LED here. These are light pipe type needles here. So you can see that it's clear plastic here. So this red LED here makes this needle light up red. The amber LED makes this part of the gauge light up orange. And so if we take a look here, we also have some LEDs here for yellow and a green one here, which if we look through here, you can see maintenance required. And then this one over here is must be a high beam or something. And then tow haul, that doesn't even have the LED populated because this cluster did not come from a truck that had the tow package. But we can take a look at like these over here, the seat belt, auto LSD, tire pressure, and battery. And those LEDs would be here. So if we sort of compare it, we've got red, red, and yellow, which of course that means this airbag light lights up red, the auto LSD lights up red, and the tire pressure lights up yellow. Battery light is this one here. That's a red one. So see, if we were to change the gauge colors, we wouldn't have to change these. We wouldn't have to change these. We just change these amber ones here that light up this part of the gauge and change those to white. So it wouldn't be that many LEDs that would have to change, because none of the other idiot light types would really have to change. So for example, on here we can see ABS and RSCA off. Those are, this one here yellow, and I don't know what this function would have been. This gauge doesn't have it. Oh, well, that's interesting. So this one doesn't have the ABS light. It just has a yellow one here and a yellow one here. So I'm not sure what this one is doing. But we have an amber one here for the gauge. We have a red one here for the needle. And then if we go up here on top, we can see low gas, seat belt, windshield wiper, yellow, red, yellow. So the seat belt would of course light up red, low gas, and windshield wiper would light up yellow. Amber makes the gauge face light up, and the red one makes the needle light up. So we just have to change these amber ones to white to make this look a little more modern. So there's not quite as many of them as I thought. I haven't figured out what these other ICs do yet here, but these are probably voltage regulators, and we got some capacitors and things like that here. Opto isolators. But these being the main three here, which makes sense why they're covered up in anti-tamper, anti-corrosion, conformal coating. Interesting stuff. All right, next step, I'm going to pull up the wiring diagram and we will get this connected. You see I put this back on here to make this move so we can observe the operation of this voltage gauge here. So, and these stepper motors just clip in here. And from my experience working on these clusters in the past, there are just some contacts on the bottom of these motors that touch the board in there. So you can just pop these out of here. It's in there. Or maybe it is soldered in there. Maybe those leads are soldered. On the other ones I've worked on, they just make contact in there. Maybe these are soldered. I'll take a look at that. All right, I'll come back to you. Okay, so it turns out that these stepper motors are actually soldered in. I removed the speedometer one here, and there are, I'll take a look at this one so you can see here. Let me grab my poker tool here. So on this motor you can see there are 2 large pins here and here, and there are 4 smaller ones, 2 on this side and 2 here that need to be unsoldered to be able to remove this little stepper motor from here. Here you can see I've removed it from here and here. CP1, these 2 pins, and SP1, these 2 pins here. And all of these motors are the same. 2 large pins, 2 small pins, 2 small pins. Same thing. 2 large, 2 small, 2 small. Same thing here. So it's unusual. So a number of years ago, I do a lot of stuff with custom Victory motorcycles. And these are the parts out of the inside of a Victory motorcycle speedometer. And this is the stepper motors that they use, which are similar, but a little bit different, as these have got integrated LEDs in them that light up through this light pipe here. And these just clip onto the board, but they've just got these mechanical fingers that make contact on the board. In fact, I made some adapter circuit boards to mount these on as I was doing custom gauges. I took some old aircraft gauges and had custom-made faces made that look like old B-52 bomber gauges, and then I would mount the stepper motor inside and run wires out to the speedometer, which I actually took apart, resoldered, made a new board for, that kind of a thing. So that's interesting that Victory on a motorcycle with all the vibration just uses mechanical contacts, yet on a car or a truck they're actually soldered in. So very interesting. But all right, I got one of the motors off. I thought I could show you guys that part. I didn't show you the actual desoldering part, which I probably should show you. Maybe I'll after I get this powered up, maybe I'll remove another motor and show you guys how to do that. But you'll need a good soldering iron, some soldering wick, patience, and some skill to be able to replace one of those motors. So, okay, so I'm going to try and do this freehand here. I know this is not the greatest, but here is the wiring diagram, and they call the speedometer the combination meter. And so we can see here that we have ignition on pin 20, battery on pin 18. That comes in, and then we have a ground here, and I know that there's a lighting circuit. So if we look at our speedometer cluster here, we say, how do we know what's what? And if we flip it over, thankfully the board is labeled, and we can see that in here it's labeled 1 on the top here, 20 there, 21, and 40 here. So this is pin 1 here. So if we flip this over, I have put a dot on the board right here to signify pin 1, and we know that this is pin 20 here. And again, if we look at our schematic, we see that the ignition line is pin 20 and the battery is on pin 18. So if we take a look here at our circuit, we can see that we've got 2 heavy-duty traces here going to these 2 diodes, and that 39 and 40 are tied together, and 39 and 40 here are both going to ground. So we should be able to connect 12 volts here and ground here and get this to power up. There is also a lighting pin which I need to find on the schematic, which will make the lights light up. And so I'm going to just tack on some jumper wires here, and for testing purposes, and we'll get this connected. So hang tight. I'm going to tack on some wires, and let me find that lighting wire, and I'll be right back. Okay, so we have my lambda regulated power supply connected here, and this is a current and voltage regulated power supply. And I have some bodge wires attached. The red is the battery line, the yellow is the ignition line, we have ground, and then I found the illumination line here. And let's see what this does here. So I'm just going to connect the battery and the ground, battery, ignition, and ground here. And I currently have this set for 12 volts, but I have the current down. And so if I start to bring this up a little bit, we see some fluctuation here. But I don't think we quite have enough current because this is pretty low. Oh, we have some signs of life here, but the voltage is pretty low here. But things are looking right, so bring the current up. Looks like we're drawing just under a half an amp here. And our board has come to life. And I can see that this unit had 242,000 miles on it. And I don't know what this illumination line does, but let's see if we connect this. Oh, shuts off. Our power supply freaks out. It does not like that. Connect it to ground. Doesn't seem to do anything. So, I'm not sure what the illumination line does here. I'll have to do some more research, but we can see here that our speedometer is powered up. So let's see if it does do the auto calibration like I thought it would. So I'm going to just take all these needles and turn them this way here. Now I just unplugged the power line here, so I'm just going to plug this in, and let's watch these needles here. I'm trying to do this one-handed here, so let's see here. Yep, and see how the needles all swing down and they hit their 0 mark, and then they move up to where they're supposed to be. So let's watch that again. And I'm just going to move in a little bit closer so you can watch the gauges here. Boop, boop, they move down. And the volt gauge here is the one we're most interested in. So this is the volt gauge here, of course. And if I vary the power supply up and down, you can see it moves up and down. It's kind of slow moving here, but it moves. And so we'll have to do some calibration on that and see if what its range is here, but way off the chart. See, and it seems to stop right about there. That must be, I must not have it quite set right. There we go, I moved it a little bit. So we can watch that move. Let me grab the overlay here. And I should have put the overlay on, but I wanted you guys to see the LEDs. So if we kind of take a look here, this dial would normally be in here. And so right now I've got the power supply turned down to about 9 volts there. And I'd have to hook up a real meter, and you can see that this is about at the bottom of its range here. So if I turn this up to about the middle here, which, what would that be, 14 volts or so, which would be about normal running voltage. And we look at our power supply gauge here, we're at about 12 and a half, 13 volts, something like that. So it's pretty close. I'll connect up a fluke meter here and we'll take a good look and we'll see if we can't calibrate it exactly. Hold on. Okay, let's try this again. So I've added the escutcheon on here and I have it set for about 14 volts here. So if I drop this down to 9 on our calibrated fluke, we're just below 9. We can see that the voltage is at 9. And we know that our middle point should be 14 volts. And it's about, and see, I'm actually off a little bit, but you can see that we're at 14 volts. I'm trying to avoid the glare, so I'm off angle a little bit, so the needle here looks like it's off center, but if I get straight on, it's actually right on. But so we're at about 14 volts there. What happens if we go up to 19? Eek, scary. 19, and we are off the scale there. Yep. So it looks like our voltmeter on this gauge is working pretty good. 14 right on the nose there. And if I were to hook up a variable resistor, we could make all these other gauges work, that kind of a thing. But we have made that work. I just haven't figured out what the illumination line does. I'm going to have to do some research on that. But you can see now how our low fuel light is on and that kind of thing. And I just have this sitting here. And of course, because it's not receiving the signals for all this other stuff, we're getting dash lights on like crazy. So, and then I just pop that little LCD just barely back in there. So we can see how many miles we're on this. But there we go. It works. Okay, so in conclusion, what we have learned is that in order to power up the speedometer cluster, we only need pin 20, pin 18 connected to positive 12 volts. This is the battery and this is the ignition circuit. Battery is the always on supplied 12 volts, but for our testing, if we just tie pins 18 and 20 together, and we have pin 40 tied to ground, that's all we need to make the speedometer work. And as you can see here, I tied my wires onto these big diodes just because it was easy, but you can see that our battery line here is pin 18. We learned that when looking at the circuit that this is pin 1, this is pin 20, and so we got 20, 19, 18. Here's our battery line here, and rather than just tie the wire to here, I just made it easier and connected it to here. And pin 20 is our ignition line, and again that connects to this diode. So I just have them tied together here. And then pin 40 is our ground. And we learned that when we look at the back of the speedometer, where pin 1 is, where pin 40 is. So now we know, because that's not visible from the outside. The Toyota wiring diagram does show a plug, but I wasn't 100% sure where pin 1 is. So we've learned how to make this work, how to power it up on the bench, how to calibrate it, how to make sure that that voltage works, how to remove the stepper motor from the circuit board that they are soldered on. And I actually, in fact, put this one back in and resoldered it back in there just to make sure that it would still work. And it does. So now I feel confident that I can pull, once I figure out how to pull my speedometer out of my 2010 Tundra, that I can safely get it torn apart and that I can safely replace that stepper motor and that I can safely test mine without burning it up, destroying it, that sort of thing. And know that I can do a repair, and if I so decide to, do a modification and change the LEDs from the ugly orange to a much more nicer, cleaner looking white, if I decide to. Which that might be interesting to experiment, to order some white and some blue LEDs of various colors and brightnesses and see what it looks like with this test unit. And decide if that's something I really want to do in my own personal vehicle. So I hope this was helpful, hope it was beneficial, hope somebody can get some information from this. So in the meantime, click like and subscribe, please. This channel is new, and we'll be adding more content shortly.